Math 3, Unit 10. We're going to go ahead and pick back up here on question 9. So we found our 50-degree reference angle. The next thing they want us to do is find a positive coterminal angle. So that's talking about a positive angle that terminates at that same exact spot that's not 410 degrees. And so one option for that positive coterminal angle is actually 50 degrees, because 50 degrees and 410 degrees both terminate right there. If that doesn't make sense to you and you just want to go ahead and add 360 degrees here, and you get 770 degrees, that is also a positive coterminal angle. You could actually you could add 360 multiple times and get multiple positive coterminal angles. Now, a negative coterminal angle, when we take 410 minus 360, we get 50 degrees. That is not a negative coterminal angle. That's still positive. And so we would need to subtract another 360 degrees there in order to get a negative coterminal angle. And so when we do that, you end up getting negative 310 degrees, which is a negative coterminal angle. Number 10, find the missing coordinate for the point on the unit circle. So here they've given us, this is our x value, we need to find the y value. This right here is the x value, which is negative 24 over 25, and we need to find that y value right here. We have this is a 1 unit circle. So if we're dealing with the denominator of 25, we want to change 1 to have a denominator of 25. We'd write that as 25 over 25. So in order to find the y value, we would use the Pythagorean theorem. We're going to end up, this is going to have a denominator of 25 as well. So since we know all of them are going to have a denominator of 25, when we're dealing with the Pythagorean theorem, we only have to deal with the numerators. And so we can write this as y squared plus negative 24 squared equals 25 squared. So y squared plus, and negative 24 squared is 576. 25 squared is 625. To solve for y, we then subtract 576 to both sides. We get y squared equals 49. Take the square root of both sides, and y equals 7. So right here, that is 7. So that means that the coordinate pair, or the y value of the coordinate pair, is 7 over 25. When you're doing this on your test, make sure you pay attention. Like, if this is going up, it's positive, but if the triangle had been flipped and going down, then the y value would have been negative. So it's important to get the correct signs with your order pairs. So here the point is negative 24 over 25 and 7 over 25. We know that sine is dealing with the y value, cosine is dealing with the x, and tangent is y over x. So based on this information, the sine of theta is 7 over 25. Cosine is negative 24 over 25. And then sine is y over x, which will end up being 7 over negative 24. Sketch in standard position. So we have 3 pi over 4. So we're going to go ahead and write our unit circle. So if my denominator is 4, in order for this to reduce to be 2 pi, we would need 8 pi on top. Over here, this would be 4 pi over 4. And then half of 4 is 2 pi over 4. And then down here we would have, 6 pi over 4. Okay. So 3 pi over 4 is in quadrant 2. And so in standard position, that is 3 pi over 4. So we get our unit circle, and if you actually look here, 3 pi over 4 is right here. And that order pair is negative root 2 over 2, positive root 2 over 2. So I'm going to go ahead and write that order pair down here, negative root 2 over 2 and positive root 2 over 2. So again, we have our y value, our x value, and y over x. So sine is the y value, root 2 over 2. Cosine is the x, negative root 2 over 2. And tangent would be y root 2 over x, negative root 2, and that reduces to be negative 1. Number 12. Sketch in standard position, 420 degrees. You will notice there that 420 degrees is more than 360, so we know we'd go one whole loop around to make 360. To figure out what is left, we subtract, and 420 minus 360 is 60 degrees. And so we know 60 degrees is less than 90, so it's going to end up in quadrant 1. And we would label that as 420 degrees. We also know at this point the reference angle is going to be 60 degrees. It's at the 60 degree mark. And so since we're dealing with degrees, we're going to write all of this stuff. Actually, when we're finding this, we're finding the ordered pair. So here's our 60 degree mark. My ordered pair is 1/2 comma root 3 over 2. 1/2 root 3 over 2. And so again, sine is y, cosine's x, tangent is y over x. So sine is root 3 over 2, cosine is 1/2, and then tangent is root 3 over 1, which is root 3. Convert 200 degrees to radians. If we want to convert to radians, we take 200 degrees and we multiply it by pi over 180. You can even think of this if you just multiply straight across, 200 pi over 180. We can reduce by canceling out zeros, and then both of these are divisible by 2, so that becomes 10 and 9, and so in radians this is 10 pi over 9. 14. Find sine of c plus cosine of c given this isosceles triangle. So even though it's not drawn great, in order to find sine and cosine, you always need a 90-degree angle. So we're going to go ahead and make a 90-degree angle. When I do that, it bisects line AC, making each of these sides 12. And so if I'm dealing with C, I need to know my height here. And so in order to find that, we'd use our Pythagorean theorem. And so I have a squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. In order to solve for a, I would subtract 144 to both sides. We have a squared equals 25. Take the square root of both sides, and a equals 5. So the height there is 5. We have sine of c plus cosine of c. And so based on our trig function, SOHCAHTOA, we know that sine is opposite over hypotenuse. So from sine c, opposite is 5 over the hypotenuse is 13. Plus for cosine c, cosine is adjacent over hypotenuse. So adjacent to c is 12 over hypotenuse is 13. And you can add those together to get 17 over 13, which is your answer. Without using a calculator, write an equation for the solution of x. So again here, you could use sine, cosine, or tangent. If I start with sine, I have sine of x. Again, our trig functions, SOHCAHTOA. Sine is opposite, which is 5, over hypotenuse, which is 13. Anytime you're trying to find the degree, you are doing the inverse function. So that would be sine to the -1 gives us the inverse function of 5 over 13 equals x. And that would solve for the degree. If you're doing cosine, if I go cosine of x is adjacent, which is 12 over hypotenuse, which is 13. And then to solve this for x, it would actually be the inverse function of cosine. So cosine to -1 of 12 over 13 equals the degree, or x. And then lastly, we have tangent. So tangent of x, tangent is opposite over adjacent, so 5 over 12. And then we'd need the inverse function for tangent. So tangent of -1 of 5 over 12 equals x. 16, sketch in standard position, -pi over 4. So again, I would look here at my unit circle. If you're looking here at the unit circle, I'd look at the positive. Positive pi over 4 is at the 45-degree mark, or it's 1, 2 marks in. And so negative pi over 4 would be down 2 marks, or at the 315-degree mark. And so if I go down here, this is where negative pi over 4 would be located. And so that is sketched in standard position. Now they want us to find sine, cosine, and tangent of that. So at that 315-degree mark, this here, which is negative pi over 4, my ordered pair is root 2 over 2 and negative root 2 over 2. And so sine is y, cosine's x, tangent is y over x. And so my y value is negative root 2 over 2. Cosine value is root 2 over 2. And then tangent is negative root 2 over root 2, which reduces to be negative 1. And that is it for the review.